I want to talk with you a little bit about how programming actually works, and lay out the workflow of how we go from a flowchart to something that could be a program. To begin with that, we first need to clarify some terminology. We talked a little bit about or mentioned programming languages, and talked about their programs, but we should get a clearer sense of what these things actually are. So a programming language is an unambiguous artificial language that is made up of a set of symbols, which we call the vocabulary, and grammatical rules, which we call the syntax, which define how the vocabulary can be strung together to instruct a machine. Pay attention here to the point of unambiguous. We mentioned this in some of the previous videos, that natural languages are often ambiguous. A machine cannot deal with that ambiguity, so programming languages must be unambiguous. And they're artificial because they're made up. A program then is a set of instructions in one or multiple programming languages, so following the grammatical rules, using the sets of symbols or the vocabulary that specifies the behavior of a machine. So you use a programming language to make a program, or you use multiple programming languages to make a program. Compilation or interpretation is the verification of a program and its translation into machine-readable instructions of a specific platform. So you can perhaps write some Python code, and that by itself isn't yet executable by a machine. You have to use the Python interpreter through which you run your Python program, and the interpreter then turns your program into something the machine can do something with. But that happens all at runtime, for instance. So that would be interpretation. For compilation, you will use something like C compiler or Fortran compiler, and that verifies your program before runtime. Cool. So that means that there are really two broad families of programming languages. I just alluded to it. The first one is interpreted. Here, an additional program is necessary to take in the commands. So your program, right, you hand it to that different program to check the syntax and translate to machine language as it's executed. So Python, Unix shell, MATLAB, etc. These are good examples for interpreted languages. Compiled then means that programs are translated and saved in machine language as an executable, and when you run the thing, no additional program is necessary. Languages like this are C or C++ or Fortran. So the difference here is that your web browser that you're probably using right now to watch this has been compiled. It's an executable. It's Firefox or Chrome or something that you downloaded, installed on your machine, and it's running without the need of some other program to make sure that it is executable or it's syntactically correct. For Python, this is different. You need to have a certain Python interpreter to take the code, and then you, on the command line, you might say Python and execute my little Python script. This is an important distinction, as it often relates to runtime and some other things. For instance, how well you can move your program from one machine to the other, but many other things come into play there. Okay, so with that now, we know what a programming language is, right? Vocabulary, syntax describing the grammar rules that the vocabulary can be strung together. A program is a set of instructions that tell the machine to do something, and programs can be either written in interpreted languages, often called scripts, then, or in compiled languages to make executables. Great. So now for the programming, you go ahead and open a text editor. There are a plethora of text editors out there, something like VI, Notepad, Emacs, some more advanced editors like Spider for Python. These are IDEs, integrated development environments. They come with a whole bunch of bells and whistles where you have a text editor and a little window where you can execute your code, and then another window where it shows the output. It's all kind of integrated, hence the name, to make the development a little faster, supposedly. Jupyter Notebook code cells. The one important thing to keep in mind here, do not use any kind of word processing software. So, MS Word, Google Docs, LibreOffice, all of these things are out because they do not save pure text files. They could, but they usually don't. So you do want just a simple text editor. I show an example down here. This is one text editor that I use, and one nice feature that some text editors come with is syntax highlighting. So you can see that different words here are colored differently, and you don't need to know what the meaning of this is, but you can hopefully understand that this makes reading the code a little bit easier once you understand, what is what here, right? So with is a keyword of the language, Python. It's part of the vocabulary, so is the equal sign. There's some constants here, like false, 1 and 2, they have a different color, and so forth. So that's quite useful. When you choose a text editor, keep that in mind. You'll find that notebooks also syntax highlight. Next step is translating your mental. Not all flowcharts are written down, but you can, or you should not, forego the effort of kind of structuring your program in your head, at least. Ideally, in the beginning, you do write things down. For simple things, it might work with just a mental flowchart. So you translate that, or some of its components, right? If you have a very complex thing, you probably want to start with some of the boxes into a set of instructions according to the rules of the program language of choice. Okay, so down here is an example from last time. We had this flowchart for the course, and now I can map that into perhaps a set of functions. So I just very high level define a function that is worked through the lecture. I give it a parameter that's n. Give feedback, perhaps with some comment text. The body of the function could be like connect to the Slack channel and post something witty that is given here as the comment text, and perhaps also send an email at the same time. Try examples is another function for module n. Work the exercises, work through the lab, and then there's a main function here, basically the body of the program that would then link these function components together in the right order to resemble this flowchart. Cool. Once you've done that, ideally, you will perhaps go back and write one function, work through lecture n, and then test it, right? So you will test all the elements of your program for syntactical correctness. So that means you ask either the interpreter or the compiler whether they think this is okay. They'll give a thumbs up or down. Usually the thumbs down comes with some error messages. So down here, I define a list that contains 2 elements, 1 and 2. Indexing often starts with the index 0. So this list, and we'll talk about that in later video in more detail, has entries at index 0 and at index 1. But I'm asking for an entry at index 4 here. So really that's the fifth element, right? Index 0, 1, 2, 3, 4. 4, but fifth element. Then the Python interpreter, so there's all Python here, tells me that there's an index error, list index out of range. Okay, that tells me that I assumed the list was longer than it actually was. Okay, next error here is I use an X, and there's a name error. Name X is not defined. Huh. So I probably haven't made a variable that's called X yet. And then down here, I call a program, run underscore this underscore program. This is a function. Functions in Python are indicated with the round braces. And I get a name error, name, run this program is not defined because I don't have a function like that. So you get a sense that if your program isn't syntactically correct, the interpreter or the compiler is going to give you some error messages, and it usually gives you a line number. I do this here on the command line for Python. It's always line 1, but you need to learn to read those errors and figure out how to fix them. Like ignoring the error messages is not a great approach. Get comfortable with these rather terse statements that you get and figure out what you do wrong in the line that is being given to you by the interpreter. Okay, and then fix it. So I could change this here to a 1 and then I'd get 2 back. Cool. So when you have these errors, you fix them and you go back to 3. So there's a whole lot of fixing and rerunning and fixing and testing and fixing and testing. You should make sure that your tests really touch on all elements of your program. Otherwise, later, when you think everything's fixed, you end up in a branch of your program that hasn't been tested, and then there's new errors that need to be fixed. Okay, and then the next part, which is really the fun part, is testing your program for semantical errors. That are mistakes in your translation of the flowchart, assuming that your mental model of the program is correct. You still make errors in the translation of getting from your flowchart to the code. Of course, your flowchart can also be wrong, but that still counts as semantical error because you assumed that you're expressing your thoughts in a way that the interpreter would handle and give you the result that you expect. But you're misunderstanding how the interpreter actually handles that set of instructions, and that's on you. So you've got to fix it because the interpreter or language is pretty clear, unambiguous about how it deals with certain situations. So here's a simple example. Import time as a package that deals with time in Python. I define a variable x, set it to 1, and then I execute a while loop, and we'll talk about all of that in the next lectures. While x is smaller than 2, print x, and then sleep for a second, and execute this. And you'll see that I get 1, 1, 1, 1, 1, 1, 1. And that's okay if you want to write an infinite loop. Sometimes that is actually a thing that we do want to do. But most of the time, we actually want to do something with x inside of this loop, perhaps increase its value so that we reach this abortion criterion here and exit that loop and move on with your life. I only added this time.sleep here because if I didn't, I'd get a whole bunch of 1s printed to my screen that that just run away from me and I couldn't make that nice screenshot here. So there are lots of ways to make semantical errors. Homework 1 contains even some in the flowchart that often also easily translate into code, right? Do you mean less than or less or equal than? Or did you flip things around in your head? There's a sign error and it should actually be greater than, and so forth, right? So for that, again, you find the errors, fix them, and you go back to 3, because now you've changed the code, and there's a great chance that the syntax is wrong. Believe it or not. Once all of that is done, we can claim success, and that is often followed by the urge to add features. So we go back to flowcharting and see how you can expand your program's abilities, and hopefully do so in a way that is sustainable, that you create code that's easy to maintain later. And we'll talk about what that means at some point in the future too.